Welcome to the ThunderStruck Motors tutorial covering BMS wiring and testing. Please read the BMS manual from our website. Important details are skipped here to keep the tutorial short. Our putty installation tutorial is recommended. Wear safety glasses and insulated gloves to protect against short circuits and electric shock. A stubby screwdriver and an insulated wrench can help prevent shorts. Never lay tools or hardware on the pack or near conductors. Essential equipment includes the ThunderStruck BMS with harness and test board, a soldering iron, heat gun, knife, wire cutters, stripper, crimper, ring terminals, shrink wrap, terminal tools, and a voltmeter. This tutorial uses a pack of 4 Leaf modules, each with 2 cells in series. A 12-cell harness will be modified for this 8-cell pack. The cell harness wires are numbered along their length. Separate the wires labeled 9 to 12, cut them short, and join them to the number 8 wire. This completes circuits for the 12-cell measurement chip called an LTC. Strip about ½ inch of insulation from the ends of the unused wires. Remove a ½ inch section of insulation from the number 8 wire where the unused wires will be joined. A stripper and a knife is used to remove the insulation. Twist the unused wires onto the exposed number 8 wire and solder the wire group. Wait for the solder to flow into all the wires for a good connection. Add shrink wrap over the solder joint. Each remaining wire receives a ring terminal on the cell end. Wires may be cut to length if desired. Service calls about cell measurement errors are often attributed to loose or corroded connections. Many wire crimping tools available on the market do not curl the terminal into the wire and will loosen over time. For this reason, each wire terminal will be crimped and soldered. If unfamiliar with soldering, practice is recommended. Heat the part with the iron before adding solder for the best results. Shrink tubing is slipped onto each wire before crimping. This seals the connection and minimizes exposed metal. This is repeated for the 8 remaining wires. Wires are connected to the cell terminals in wire number sequence, starting with wire 0. This is the black wire, which is attached to the pack most negative terminal, called B-. An insulated wrench prevents short circuits between cell terminals. Now wires number 1 to 8 are attached in sequence of increasing pack voltage. Notice the positions of positive cell terminals in this leaf pack. Ring terminals will be connected at these points. Other cell types will have different characteristics. voltmeter measurements can help determine connection points for other pack types. Positive, plus red, and negative, minus black indications are common. The center terminal is the connection between positive and negative inside each of the Leaf modules. When finished, 8 cells have been connected to the harness, which is now ready for testing. For your project, make sure proper torque values are used for each attachment. Terminal attachment convention suggests larger terminals install below smaller terminals, so your BMS connections may be on top. Connect the test board to the harness and lay it on a non-conductive surface for measurements with a voltmeter. The short black lead was added here to keep test leads from crossing on the board. Optionally, wrap test probes with electrical tape. Attach the voltmeter negative probe to the black lead. Using the positive test probe, touch the numbered pads from C1 to C12 in sequence. You may want to record the measurements. They can be used in the verification process later. Check polarity. If you see a minus sign, then check to be sure your wires are not reversed. Measurements in this test are increasing by about 4 volts each cell. Cells 8 to 12 show the same measurement, 32 volts. This verifies the connection made between cell 8 and the unused wires. This next section will show what happens if 2 wires are installed in the wrong order, in this case by reversing wires 7 and 8. Don't actually do this. This simply demonstrates how to recognize this kind of error. Since the BMS is not connected, this can be demonstrated safely using the test board. As you can see, cell measurements are correct until reading cell 7, which now shows 32 volts. Measuring cells 8 to 12 shows 28 volts. This exposes a wiring error. Notice that the polarity does not change, but the voltage steps are incorrect. Any unexpected reading must be corrected before connecting to the BMS. Here are some of the most common reasons for BMS trouble. Poor connections create unreliable measurements. Skipping the harness test. Always test a new harness or a modified installation. The BMS can be damaged if reading cells while changing pack connections. Before modifications, disconnect all harnesses from BMS cases. This protects against voltage spikes. Test and verify when finished. Polarity is important. Look for the minus sign on your digital voltmeter and keep the test board. Now to verify and configure the BMS. Connect the tested harness and interface cable, then open PuTTY and provide 12 volts to the BMS. These examples are for a Leaf pack. Use settings from your cell specs. You may see high voltage cutoff errors on startup. Enter Show Cells and check listed voltages. If you get unexpected readings, disconnect the harness from the BMS case and investigate. Voltage settings are entered to configure the Leaf cells. Set HVC 4.2, set LVC 3.2, set BV min 3.3, and enter Show Config to verify the settings. Enter Show LTC, The last two columns represent the discovered and expected cells. Enter lock, show LTC again, and the columns match. The BMS light flashes green. Enter Enable Balance to start cell balancing. Enter Enable CAN-term to terminate CAN bus inside the BMS. Typical for systems using our BMS and EVCC. The command show lists system status. This concludes the BMS wiring and testing tutorial. Please return to this channel for info about other ThunderStruck EV systems.